Welcome and thank you for downloading the Studio podcast.
Who of you is actually Dutch? Okay. So there are a few who do not understand Dutch, isn't it? Yeah. Okay. Good. Otherwise, I was at the wrong class. First, my sincere compliments that you're here this early. Because, I was a student in Groningen, and in Groningen, Thursday night was stappenavond, was the night to go out. So Friday morning was no-no. But for you, maybe it's Friday night. Is Friday night the evening? No, it's Thursday night. Wow. Well, then my compliments are even stronger. I have 2 hours. And during these 2 hours, I address sustainability. But I address it in my way, which basically means that it contains one thing, and that is the view of the Earth, which is basically, if you want, the urgency. So why is it that sustainability is important at all? The second is to show you a problem, the way we work, the way our society is. At the moment, it's not really sustainable. And then third, I'm going to show you solutions. Because at the end, I would like that you get out of this class optimistic. There's no way you can reach anything when you're pessimistic. Pessimism is not a good attitude. I don't want you to be optimistic in a way that you say, okay, everything is okay, because you have to do something. But if it is pessimistic, who of you has ever done a sport activity like a race? You know, a sportive race. Now, who of you who have a sportive race thinks that if you are pessimistic, like, I'm never going to win, who thinks that if you have that attitude that you can win? Well, one. I'm not even sure you're honest. Because, I mean, it doesn't work. Okay, if you think you win, then still there's a big chance that you don't win. But at least you give it a try. What you see here in front of you, I have to apologize for the beamer. The beamer has a lamp which is basically at its end, but the system here is such that we can't change the lamp unless it's really not doing it anymore. So later on, maybe we should throw something and then we get a new lamp. We can dim the light a little bit more, but I'm afraid you fall asleep. No? Okay. This is better? Okay, what you see here is the Netherlands. And in fact, this picture was taken already 26 years ago. And I was in the space shuttle above Denmark, looking in the southwest direction. So I just indicate with the cursor. This is the island of Texel. This is North Holland. This is the South Holland Islands. Here you have Belgium. This is the UK. It's the Channel. And here going to France, and this is the River Seine. So this is the picture you see when you go up and you look down. If you look at those clouds, if you look carefully, you see that underneath each cloud there's a little shade. And that's the reason why it looks so transparent, so glassy, the atmosphere. Anyhow, since that time, I have developed more and more the thinking about sustainability. And sustainability for me, if you talk about branding, is three things. It's you, the youth, innovation, and sustainability. Well, let's talk about the youth first. You realize that sustainability is all about future. It's all about taking care, all about, making sure in the future you have the same or better capabilities and environment than you have today. That is sustainability. Now, very simply, in 50 years from now, you're still there and I'm not. So for me, it's, if you want, an obligation to make sure that when you are my age, that you can do at least the same things, or maybe even better. But I should not use up resources such that you cannot use them in the future. I should not destroy natural environments, beautiful parks or whatever, such that you cannot use them in the future. I should find solutions for airplanes such that they can have kerosene, which is not anymore this pollutant as of today, otherwise you can't fly in the future. And so on and so on. That is what sustainability is. But we don't do it right at the moment. I come to this point. And that's the reason why we need to change. And that's what's called innovation. And in fact, you could say that, or I do, I'm just jealous. I'm jealous at you because the time which we go on, which we see now, is absolutely fantastic. I mean, look at the Dutch day before yesterday. You know, they talk about barre tijden. They talk about, you know, the really bad times. It's difficult. The only thing they talk about, though, is economy. And as long as you have enough to eat, who cares? And to drink. No, but the thing is that the times are changing because we don't do it right. We are in an industrial revolution end period. And we already know for 30 years or 40 years that we can't go on like this. I don't know whether you know about the report of the Club of Rome, the little booklet, Limits to Growth, 1972. Already then we knew we can't go on like this. But in those days we didn't have the alternative. It was like, oh yes, we have a problem, but we don't have the solution. But now we do. Now we do have solutions. And they pop up everywhere. Beautiful developments. The whole area is open. Everybody of you can invent new things. That is what is beautiful about the next time which is going to come. I bring you back to the Space Shuttle Challenger in this case. And here you see the Challenger. I was sitting in there in 1985 with 7 colleagues. You see the last minute. You sit 2 hours during the countdown, you know, in your seat, but the seat is of course backward because the shuttle stands up. Normally there are 8,000 people working at the space shuttle. At this very moment, all these people are at 6 kilometers distance. And we get the auto sequence start. I wonder why, if you don't mind, because there's something with the sound. I'm going to find out what this is. Boom, 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 boom. Yeah.
Systems are looking real good.
So this is the last minute.
Minus 1 minute.
There's a countdown sequence which is going for many hours. The last 2 hours we are sitting in the space shuttle. What you see is that at 31 seconds before launch, the computers of the space shuttle take over, so also the countdown. You see the big water tower. Just before launch, 20,000 gallons of water is going to be poured underneath the space shuttle to absorb the shock wave. Because if the rocket engines go on, you get a big shock wave.
And we have a go for auto sequence start.
Auto sequence starts, so the space shuttle computers take it over.
Computers have now armed.
The next thing you're going to see is that 10 seconds before launch, the 3 main engines, the rocket engines, they will be ignited. They are quickly steered to check whether they can move, and then the side rockets go up.
Minus 10 for go for main engine start. 5, 4, 3, 2, 1. We have ignition and liftoff. Liftoff with Challenger and the spacecraft V1 mission. The shuttle has cleared the tower.
Controlling roll program initiated. There's 102-degree roll. Let's see, ship in the proper attitude for flight downrange.
Soon you will hear we are throttling down. So you heard the call, we are shuttling down, and that is the call where the space shuttle engines are throttled down a little bit because the space shuttle otherwise would go too quickly, too fast. The space shuttle is accelerating with 3 Gs, so you're 3 times your body weight, which means that each second you go 100 kilometers per hour faster. That's what 3 Gs is about. When you throttle down is at the time when the space shuttle goes through the sound barrier, 1,000 kilometers an hour. So what you just saw was accelerating from 0 to 1,000. And the shuttle continues this way. First you get the solid rocket boosters. They'll be separated when they burn out after 2 minutes. And then the shuttle continues with the 3 main engines, which you see there in the middle. It takes 8 minutes from launch to be here. That's all. And at 300 kilometers, where we were, 320 to be exact, the space shuttle engines, they go off. Main engine cut off. And then you float, and then is what you see outside is what you see here. I would like to bring you with me. Imagine that you are here in the black. And I can tell you that the very first time when I looked out of the window, I thought, well, wait a minute, I'm outside. If I don't do anything, I'm not going to be back. Because you are basically in balance of the centrifugal acceleration around the Earth and the gravity pull. And if you don't do anything, you'll just stay there. If the space shuttle wants to re-enter, wants to come back to the Earth, it first has to reduce its speed. Turning around, tail first, and then ignite the engines. Did I want to come back? No, but it's not whether you want to come back, it's just that you realize that you're somewhere else. What I also realize is that the space itself, what you see there, is basically nothing. It's black. It's 200 degrees minus. There's no air, there's no life, there's no history. There's no future. There's nothing to get. You know, normally if we are on an exploration, you know, in the past in history, people have always gone somewhere, investigating, explore. Marco Polo, Columbus. And these people, they always came back with treasures, with gold, slaves, with all kinds of people and things. But now you go into space, and my goodness, there's nothing. And then you turn around and you look at the Earth, and you see the Earth this way, and then you realize everything you know, everything which is valuable to you, your friends, your history, your family, nature, all your goods, is there. And if you then look carefully, and you ask yourself, now what is the difference between the world which you see in front of you, where all the values are, and space which is above, that's a rather alarming thin layer of transparent atmosphere. The atmosphere which you see by naked eye is only 20 kilometers. That's it. So, and that is the difference between life and death. You could also say that basically you get aware of the fact that we have quite of a danger outside, of which you don't normally not realize at all. If you walk outside and you look up, you see a blue sky and you feel totally comfortable. You have no idea that behind this blue sky there is in fact a danger. In fact, if you think about what the Earth is nothing else as a spaceship. It's a big spaceship which moves through space, and we are all on there. In fact, I'm not the only astronaut. You're all astronauts in Spaceship Earth. But you can imagine that if you think about a ship, you know, I'm also a sailor. I have a big ship. I'll show you that in the next hour. If you're on a ship on the ocean, you feel comfortable if you are aware of the fact that you have a very strong hull of steel to protect you against the dangers of space or of the ocean. But our hull of Spaceship Earth is just, you know, a little piece of air, which, if you're not afraid, you blow it away. If you are in space, Earth becomes really small. This is the South Island of New Zealand. You know, exactly on the other side of the Earth as we in Holland. And if you start your stopwatch there and you stop it when you're above the Netherlands, it's 3/4 of an hour. So the longest distance you can make on the Earth from one side all the way to the other is 3/4 of an hour. Yes, you can learn this, you can see this in a textbook, but if you yourself have perceived it to just go around the Earth in 1.5 hours, it's not large. The third element of being away is the fact that you don't feel the Earth. You're weightless. First of all, I changed, I know. But this was my coverall. I had it on the first day, I put it off, I wanted to put it in the cupboard, wrapped it up, let it, and it just rolled out and took the shape as if I was still in there. There's nothing which pulls it down. It's hard to imagine what that really means, you know. You're so used to 1G, it's always the same. You know, the gravity is not like weather. You know, weather changes, and that's why you understand weather. You know, tomorrow is different than yesterday. But gravity is the same. It's not like today is a heavy day, and tomorrow is a lighter day. No. You've always the same weight, unless you eat much. And everybody has his own little, you know, pressure on his butt. The one with, I don't know, I have to just 56 kilos, 80 kilos, maybe 85 or maybe 70 something, I don't know. But everybody has his own weight, you get used to it, and that's it. But if you're in space, you're weightless, and can you imagine that if you don't feel anything, nothing at all, and you close your eyes like this astronaut, I mean, you just don't know where you are. Not even that, you even don't know whether you move. It could be that this astronaut is just going to hit his head. He couldn't tell. Space is, to a certain extent, not very comfortable because you don't have anything. You don't have a reference. There's no rhythm. You can't dance in space. You can't move. Because if you do this, then I'll be there. You have to be very gentle. You're by far too strong for space. You know how strong? Suppose there's no gravity here. And suppose I would do like I'm doing right now. In 1 second, I lift my body with my legs. My body is exposed to 1G. So the force which I put on my legs, an acceleration of 1G of my body. Okay? 1G. 1G is 10 meters per second square. 36 kilometers per hour per second. So if this is 0G and I would do this, I would just shoot up with 36 kilometers per hour to the ceiling and hit my head. I mean, my goodness. And if I would do whoa, which is almost 2Gs, I go with 72 kilometers per hour to the ceiling. That is how much 1G is. It's amazing. But you can imagine that if you then, outside of this 1G, you're weightless, you get a completely different picture. And things are different in space from weightless point of view. Anyhow, I could talk, you know, for hours about it, of course. But the class is not about space mission. The class is not about weightlessness. Although, before I go to this, let me tell you a little joke. To talk about, again, about 1G. Because 1G is really fascinatingly fast. Is there anybody of you who's ever driven in a car which accelerates with 1G? You know, you have to drive in a real fast car, you know, like a Ferrari. A Ferrari can accelerate with 1G, which means it goes in 3-something seconds to 100. And that's bloody fast. In fact, if you do that, then you're pressed with your back against the seat with 1G. 1G is the same as this. Now, suppose you are coming into a bar, and this story for the guys is about a girl, and for the girls is about a guy. Huh? So you come into a bar, and you see some really nice person sitting on the bar, and you say, hey, I'm going to seduce her, or him. And then you come and he says, you want to ride in a Ferrari? And of course, most of the girls now would say, well, come on, I mean, I don't get myself influenced on a Ferrari. But in real life, it's different. and then, of course, at some point in time, this girl or this guy is going to ask, well, where is your Ferrari? And then you say, well, I have even something better, you know. I mean, I know a Ferrari, you sit in a Ferrari and you go like, boom, 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 and then, and you go very fast, in 3 seconds to 100, and you lean with your back against the seat with your own body weight. I can give you the same a whole night long. I can basically say, you know, we're just sitting there and just playing Ferrari. Give it a try. You know, the nice thing is, you know what the nice thing is? I know you will never forget in your life anymore what 1G is now. That is what is nice about it. Okay, the big issue. You go outside to space, you look at the Earth, and you realize it's not space which is unique. It is, in fact, the Earth. I was not the only one. Yuri Gagarin was the very first cosmonaut in 1961. Imagine, thousands of years, cultures, like the Aztecs, like the Egyptians, like the Greek, they've always looked at the skies, they looked at the stars and the planets, and they were fascinated, and they wanted to go there. And then finally, Yuri Gagarin was the very first person ever to go there. He was called cosmonaut. So it's very simple that, and very understandable that when he was in space the very first time, that the ground asked him, Yuri, how do the stars look like? How do the planets look like? And his answer was, the Earth is beautiful. It is not so interesting to look at the stars and the planets from space. Basically, they look the same as from here, at a very clear night, in the mountains, for instance. But the Earth is the really key issue. The Earth, like this here, the way they saw it from the moon. This is a spaceship, and there's only one. And the realization of what I'm just now saying, that is the fundamental issue about sustainability. That you suddenly realize, okay, there's only one Earth, it's our spaceship, we have to take care of it. It's not so heavy, it's just a matter of taking care. It's like homework. It's like making sure it's not too warm, not too cold. There's enough energy, enough water, enough food. It is something which, unfortunately, at the moment is led by religion, by governmental politics, by opinions. But in fact, what you really like to do is to say, okay, no, I'll take care of it. Just do your homework, like you do at house. One of the things which causes us trouble is oil. In the beginning, in 1930, and in fact, here you see a picture of the amount of oil which was discovered. Each peak, the first peak you see in 1940, it was Kuwait. After that, you see another peak in 1950, which was Saudi Arabia. And in the middle, around 1964, was the maximum year of the maximum discovery of oil, was Siberia. And since then, you see roughly an exponential decay of how much oil is still found. Yes, we do still find oil, like on the North Pole, but it is small compared to all the other oil. If we use today, if the whole world would use the oil of the North Pole, it would be 7 years, and then it's finished. If you now look at this yellow curve, that's the curve which indicates the amount of oil which we have used. And you see that curve going up, of course, certain predictions. The little purple curve, I will just indicate with the cursor. The purple curve is the integrated amount of oil found. And of course it flattens off because at some point in time you find less and less and less. And you see that around 2030 these two curves cross. Very roughly you could say that we have used up half of all the oil in the world, and in the next 20 years we will use up the other half. Is this a problem? Well, there's one element to it. Oil is a biofuel. It has been produced like 100 million years ago, over a period of tens of millions of years, by little algae who grabbed CO2, greenhouse gas, out of the atmosphere by photosynthesis using the energy of the sun, and produced carbohydrates, molecules which later on are in the oil. So in fact, oil is nothing else as a concentrated greenhouse gas from tens of millions of years. And if you then burn this and release again, basically, the greenhouse gas, in a short term, then you cause a problem. And you will see it with many, many elements. Nature needs cycles which are in balance. You can't have a system where nature uses 100 years to make something and you use it up in 1 year, unless you then wait 99 years to do it again. You know the result? The result is that since 1980 the Earth heats up. And I don't know what you read, but sometimes you still read that there do exist what is called climate skepticists. Well, maybe they are, but they're not scientists. All the scientists which I know, and I'm also a professor in Groningen at the Institute for Environmental Physics, everywhere we see the changes of climatic change. The Earth heats up. It doesn't mean that climates get warmer. Some of them get warmer, some of them get colder, some of them get more dry, some of them get more wet. But one thing is clear, it becomes more wild because the total atmosphere is more excited. To study now, is this a problem, then you can go and look in the past. Because in itself, let's face it, in itself, to change things does not necessarily is a problem. I mean, this faculty was not here, 200 years ago. So we do change. We make buildings, we make roads. But that's in itself not a problem. Now, what we can do is we can look in archives. You can drill in the ice of Greenland or the glacier ice of Antarctica, and you'll find layers, the old layers of snow, basically, because each year you get new snow. And these layers of snow, the snow, contain little air bubbles, and the rest, of course, is water, and it's compressed and compressed and compressed, such that it becomes ice. And if you drill deep enough, you can recover year after year the information of what was going on. In the little air bubbles, you can find the greenhouse gas, and in the water, you can find the temperature. You do that with isotopes. So this is the way you can go and dig into the past. And what you then see is what you see here. The amount of carbon dioxide, the greenhouse gas carbon dioxide, in the atmosphere in terms of parts per million, ppm. You see on the left, it goes from 180, roughly, to 280. 180 when it's cold, during the ice ages, 280 when it's in between in the warm periods. Now, realize that this is 500,000 years. 500,000 years is also about the time where humankind was developed. During this period, by the way, many kind of animals and so developed to a higher level. Why? Because the climate was relatively constant. In spite of the ice ages, we could develop warm-blooded animals. In the last 50 years, 500,000, that is what we have done. We went from 280 to 380, and in fact we are now at 390. Obviously, if you look at this, then one conclusion is that the step which we made in carbon dioxide in our atmosphere is of the same size as what is the difference between the ice age and the non-ice age. And now you get into a debate. Because now the question is, what is the consequence? And then many people, also organized in the so-called International Panel of Climatic Change, they're going to predict with models of our atmosphere what is going to happen as a result of this jump of CO2. And these models, they show different results. One reason being that the jump is so high that the predictability of those models is not so good. You can imagine. I mean, you have a model, and if you make a small step in a model, then the model is relatively okay because it has been deduced from the previous years. But if you suddenly make a big step, big change, the models are not in agreement. Now, if these models are not in agreement, you can do two things. You can act like the media, like the journalist, and it says, you see, those scientists, they even disagree with each other, so they're wrong. But that's not the correct way of acting. In fact, the situation is much more serious. The fact that they disagree means we don't know. We don't know what the future is going to be. Has it ever been this high? Yes, 60 million years ago. What kind of climate did we have on the Earth? Well, first of all, we didn't have permanent ice. The sea level was 70 meters higher than today. Second, the climate was violent. It was like a Jurassic Park. Rain, thunder, and the animals, reptiles. Because the climate was not ready to support development of warm-blooded animals. Nature has no mercy. What I mean is that we can't play games with nature which nature doesn't want. And nature, I now mean the natural laws, everything. I mean, you look at the movie from Discovery Channel, and you see a beautiful lion, and you see a beautiful deer, and then suddenly, yuckus, I mean, the lion is going to eat the deer. But that's nature. Nature is not necessarily nice. So if we don't, I mean, you have to respect nature. But in fact, what we did in the Industrial Revolution is we kind of ignored nature. We started to kind of bulldoze, and we said, okay, we just move it away. Everything, we just do it our own way. We build our own artificial world, and that is the way we like to live. But more and more we realize that you can't beat it. I mean, nature will hit back, like nature hits back with the climatic problem. Now, the real challenge now is to find a way that we live in a game, in a play with nature, in a win-win situation. This is the reason why we have always now to learn and study what's going on in nature such that we can use it. I'll give you a few examples later on, how relatively easy it is if you just open your eyes to see what the treasures are you can get from your environment to use in a way that it doesn't harm your environment. Talking about CO2 again. The question you could raise is doubling of CO2 a problem? I'll call this a scientific question. You know, you have a question and you want to find an answer. But I don't think it's the correct question. I think the correct question is different. The correct question, with responsibility at least, is do you have evidence on the basis of which you can conclude that doubling of CO2 does not lead to a catastrophe? You know, let's take another comparison. You have a bridge. And you have a bridge with 5 pillars, and one of those pillars is just exactly there where you don't want to have it. The scientific question would be, I take away the pillar and I'm going to look and study what happens. It's a nice experiment. And it is. It's interesting. But it's not responsible. Responsible means that you say, okay, before I do that, I need to have some evidence that it will not harm the bridge. The question then is, do we have evidence? And the answer to the second question is no. There's nobody that I know which can somehow assure that doubling of CO2 does not cause a problem. There's a movie made, a rather depressive movie, which then shows what's going to happen when you get a runaway of our climate. Runaway means, you know, things amplify. Give you a very simple example. Because of the climatic changes, the temperature changes, the bees, colonies of bees will die, which in fact is true. We have only 50% of the bees which we had 10 years ago. And suddenly, as there are no bees, we don't fertilize the plants, so we don't have food. We can have only artificial food. But then, you know, many people die, and then we are just very uncareful with our environment. We get all deserts, and we get dust in the air, and we change the total ecology, and at the end, there's no life anymore other than us. And then it doesn't last very long. We get into wars, and then finally we have just a few people left. That's the movie, The Age of Stupid. Has anybody seen it? Well, I think you can just download it, you know, Age of Stupid. It's not a bad movie, but it's a very sad movie. And in fact, I'm absolutely convinced it's not going to happen that way. We are too smart. For the energy problem, the solution is very simple. This is nuclear energy. You know nuclear energy. Nuclear energy is fascinating. It's this is the law. E equals mc squared. I don't know if you ever done this for yourself. You ask yourself, make a little calculation. In the Netherlands, we are using total energy use, just not only electricity, but transport and heat and everything, 3,000 petajoule. Petajoule is 10 to the 15th joule, so 3 times 10 to the 18th joule. E is equals mc squared. You take one liter of milk. This is 1 kilogram. 1 kilogram you multiply by twice the speed of light. The speed of light, 300,000 kilometers, not per hour, but per second. 3 to the 8th meter per second. Twice is 9 times 3 to the 16th meters per second. Times 1,000 grams. I get in 1 kilogram a comparable amount of energy as the whole Netherlands uses in 1 year. Fantastic. You get it for free. Nature offers you this. Well, I offer you a nuclear power plant which is extremely reliable because it has worked already for 4 billion years. It gives an output which is very, very constant. It is beautiful at a safe distance. It's really safe. It's at 140 million kilometers. And you don't have political influences. And in fact, if you want terroristic attacks, you're afraid of it, terrorists go. You'll never come back. This nuclear power plant doesn't cost you anything. And in fact, it's for everybody. And of course, I'm talking about the sun. The sun is a fantastic nuclear power plant. It's also a very modern one. It's a fusion plant. On the Earth, we have poured in billions of dollars to develop a fusion plant, and we're still not successful. But the sun is there. The sun provides us with energy in the form of light, heat, and wind. And what is important to realize for you is that the sun brings absolutely enough energy. The sun brings you 100 times more energy in the Netherlands than we're using. On the world scale, it's 8,000. In 1 hour, the sun shines the same amount of energy on the Earth as we use in a whole year. Think about the sun. I mean, you lay on the beach, you have a surface of, let's say, half a square meter. And as the sun, when it's straight up you, shines 1,000 watts, 1 kilowatt per square meter, you get 500 watts on your body. That's amazing. You're going to be baked. The sun is a lot of energy. And the beauty of the sun is, of course, nobody can owe it. So if you live somewhere and you say, okay, I take a few solar panels, it's yours. You don't have to make a deal with Shell or with Exxon or BP. No, it's just yours. And if you have too much, you take a little extension cords and you give it to your neighbor. All up to you. Nobody can claim your sun. It's fantastic. This is also the reason why you can be very optimistic. And in fact, you can't waste it also. Suppose you're in a room. You have a room with 2 opening doors with windows to the south. And the sun shines in your room and it gets too warm. What is it that you do? You just open those windows. Is that wrong? No, you're allowed to. In fact, the more we will use the natural inputs, the more we will realize that, it's much more fun. You don't need to feel bad. Because if you burn too much oil or you do something else, somehow, somewhere, you feel not very comfortable. I mean, normally you forget. But if you think about all the disasters which are due to the fossil fuels, my goodness, the wars, the pollution, the enormous differences in social standard, the ruin, some of the countries are ruined, like Nigeria. I mean, my goodness. I mean, what is going on with our society that we somehow allow this to happen? In any case, it has happened, but then for the future we can choose differently. The principle of sustainability is listed here. It's very often called cradle to cradle. What it really means is that first you need to get away from the idea that there's waste. Waste has to go somewhere. So at the end, waste can never be waste. Yeah, unless maybe you throw it in space. But if it stays here, it stays here. So you have to ask the question, what is going to be happening with the waste? You don't need waste. There's a way to make sure waste is in fact food for another cycle to this point. The second is use the current input of energy, which is the sun. Don't embark on millions of years of fossil fuel and then use them in a short time. This is going to cause you trouble. And the third thing is the biodiversity. We learn more and more that we are totally dependent on our environment. We are dependent on nature. For everything, for food, but also for medicine, for so many things. For cleaning the air, for cleaning the water, bacteria. Our whole body is full of all kinds of things. We are far away from being able to make artificial life. And that was a new insight. I mean, if you look at the 1930s and 1940s, people believed that we could do, we could master everything. People thought about having colonies in space where we'd have a whole artificial world. But the more and more we learn now, the more and more we see it is so complex. It is so beyond imagination that we can do it ourselves. By the way, did you know that Rembrandt made once a famous statement? There's only one master. It's nature. In the idea of cradle to cradle for waste, you have basically two cycles. One cycle is what we call the biocycle. The other one is the technocycle. The biocycle means you have waste which you can throw into the biosphere. But then the biosphere needs to see it as food. In fact, Nike has running shoes which are compostable. So you run in those shoes, you don't wash your socks, and after a while they are really going to stink, and then what you do is you throw them in the garden. Is this wrong? No. With Nike shoes it's okay, because after a little water, the soil is going to eat up your shoes. And then as a kind of a surprise, there's a little seed here in the back of your shoe, and after a while there's a plant coming out. And then a Nike plant, yes. No, but it's fun. Can you imagine? You have T-shirts which are compostable. And suddenly throwing away, which normally was polluting the environment, now is supporting the environment. Isn't that fun? The other one is the technocycle. The technocycle is when you have a product which can't go into the biosphere, like for instance plastics, and then you have to take that back into the industry which make the production. Not only because we don't want to pollute the environment, but we cannot afford distributing all our resources. Imagine, the Earth, this beautiful planet, went through a period of what is called geological differentiation. Because of the water, various salts got absorbed and transported, and ending up in concentrating some of our resources. That's the reason why we have mines. We have mines of copper, we have mines of gold, we have mines of iron, we have mines of tellurium, we have mines of all kinds of products. All kinds of products, like what you're talking about now. It's in mines, you know. But the reason that it's in mines, we can recover them and we can use them, like cadmium. And then we put cadmium into all kinds of products. And then we spread these products around all the world. And then finally we lose basically the concentration of that product. So that's unwise. And in fact, we can't go on that way. If some of you is interested in where are we going with our resources, you just start Googling. TNO has made quite some studies on that. And we run into real trouble if we're not careful, especially with rare earth materials, which are very important in computer elements. So computers we should not throw away, we should, get back. And the idea is that we go to a society where it is not anymore about possession, but about service. So Philips in the future will not sell a television set. No, it will sell services of TV. TV-looking services. Each 2 years they will come with a little truck and take your old TV and put in a new one. The nice thing about that is if the industry is forced to recycle, they are also forced to have high-quality products. And you don't have waste. So this is the way the Earth could work, and this is the way where we should go to. Now we are in a transition towards, from the industrial age, towards a better society. Not everybody not every country is in the same pace. In fact, here you see a list, this is 2006, of the windmills installed, and absolutely number one was Germany. Germany, because they have placed a law, which is called the feed-in law, which helps them to be number one in the sustainability development. They're still number one in the world. They have 400,000 people working in sustainable development, and they earn 3 to 5 billion euros per year on that. And maybe even more important, that when delegations of China and India, the main countries where the main problems are going to be faced, they come to Germany, because Germany has a higher level of understanding what is at stake. Where's the Netherlands? Well, in those days, the Netherlands was there. At the moment, Netherlands is number 18 in Europe. The Netherlands is not doing very well. And maybe you can help. You can help making it better. Certainly, it would be wise at some point in time to choose that direction, because that's where the market is, that's where you can earn your money. This is the one but last slide, and then we make a short break. This is one of the reasons why the Netherlands is not really doing very well. If you look at the left side here, it are the fossil fuels. The blue is gas, the yellow is oil, the brown is oil products, and the black is coal. On the left, you will see what we import on the top. We have a little from the side, this is what we get ourselves, and we have export. The Netherlands is a trade country. The Netherlands trades 4 times more than what we use. We are in Europe by far the most dependent on fossil fuel. So even if we want to go into sustainability, the government with all the lobbies of the fossil fuel world will, hinder us, because there's so much money which is going on in this trade, and there's so much money which we are dependent on. Still, however, we can do many things, and I will explain in 10 minutes. So, see you. And I really regret that I only have 2 hours to give class, because I would love to just tell you many more things. We got questions during the break about the Challenger accident, which was right after my flight. About the economy, how do you go to a sustainable economy? And I come to this point, but you will hear very often from the old-fashioned economy, especially from the fossil fuel side, that the sustainable economy is too expensive. They say it's too expensive and that's why we don't do it. But think for yourself. Is it always true that you buy the cheapest? Do you think that this suit is the cheapest suit you can get? Of course not. You just do what you can afford. In fact, culture and fashion go with the highest price, not with the lowest price. If you can find yourself and you have money enough to get yourself a beautiful mountain bike, you buy the beautiful mountain bike. So if sustainability becomes in the same area as the, let's say, the cultural plus area, everybody wants to have it. It's not a matter of cheapest, it's a matter of what you like. Okay, the next 40 minutes I go and rush through a lot of projects. And they all have to do with the solutions. I talked about the problem, but, you know, I much more like to talk about solutions. First of all, this is the way we use the heat and the energy in the Netherlands. Look at the middle, you see heat. 1/3 of all our energy we use to heat the houses and the offices. But do you realize that during the summer, much more heat is poured into your house than we need it in the winter to heat it up? So if you get storage of your heat and of your cold in the winter, and you put it in the soil and you pump it back in the summer or in the winter, you don't have a problem. In fact, houses could be neutral. The other thing you have to realize is that most of the discussion about sustainability is talking about electricity. They talk about, you know, whether I need solar panels or wind energy or versus coal or nuclear. But if I go back, on the top you see electricity, the gray bar, is only 12% of all our energy. So if people talk about the CO2 problem and then discuss maybe nuclear power is 2% of our electricity. And the electricity is 12% of the total. It is totally not relevant for the CO2. So don't get yourself being fooled. In fact, if you talk about the total amount of energy, then if you want to have that on solar, that's unpractical. Because then you need 30% of your area of the Netherlands being solar power. But you don't need to, because 1/3 is already heat. In fact, if you would have all the energy of the Netherlands with nuclear power, you need 71 nuclear power plants. Maybe one word about nuclear power, but then I stop. I don't like nuclear power at all, because of the fact that again and again it is proven that the time frame over which you take responsibility is too large. You know, like 20 years ago, people put the nuclear waste into the salt mines of Germany, and now it turns out to be wrong. And then they say, yes, but now we know better. I say, yeah, of course, because we learn. But then 20 years from now, you've learned also. And you're going to say that we're stupid now. In fact, these things always go wrong when people are too arrogant to think about very long futures. We have to do things which we can change and adapt in lifetime experience. And you do that with watches and cars and all these things. And if you do that, then we get to higher quality. And we can still change if we do something wrong. And we've always been wrong in the past. You know, with the DDT, with asbestos. But we make mistakes, but be honest about that. I'm not going much into this, but I just want to show you that if you take the Netherlands and you take the houses which you store the heat in the summer for the winter, and if you take the transportation which you make electrical, and that makes a big difference. Electrical cars, they use only 1/3 of the energy when it comes from a power station than if you use the own fuel. And you do the most simple things, then the fossil fuel the Netherlands is using, which now is 3,200 something, goes down to 800. And the rest you can do with solar. And what does it mean? It means that, and I know, because this was my house and I have solar on it, and I know exactly what you get in the Netherlands. You get in the Netherlands roughly 140 kilowatt hours per square meter per year. So it's an easy calculation. You can do it for yourself. You can look at your energy bill and you say, okay, I divide by 140, and the number of which I get out is the number of square meters of solar which I need. If you have the Netherlands like this here, 4 times these areas, it's enough. It's something like 7% of the surface area, which means, not even half of all the good positioned roofs. In fact, I made a little study on the Afsluitdijk, the big dike in the north. And if you look at the grass, 6 meters of grass, if you put solar there, the amount of energy you get in is the same as what all the cars are using. 18,000 cars a day driving 30 kilometers on that dike. Isn't that nice? A yellow stripe in the beginning, yellow stripe at the end, and you said this is energy neutral highway. Obviously, some of you would say, well, what does that cost? Well, roughly 1,500 euros per meter. With what can you compare that? Well, with maybe a sound barrier. A sound barrier in the Netherlands along to the highway costs anywhere between 2,000 and 4,000 euros. So we are already in a situation, because of the decline of the prices of solar, that putting solar on the highway, which is for the energy of the cars, is cheaper than putting a sound barrier on the highway. Another example. If you want to have a nice electrical car, you can buy yourself a Tesla. It's expensive. 80,000 euros, but it's a car which, accelerates in 3.6 seconds to 100. Real sports car. If you drive with that car 15,000 kilometers a year, the amount of solar you need is 6 times 5 meters. Price, 8,000 euros. I said to Kroijmans, who is the importer of this car, I said, why don't you sell the car and give the solar for free? It's only 10% of the cost of the car will give you the energy for the whole lifetime of the car. Isn't that fantastic? Yeah.
Don't you have to charge it for more than 20 hours?
The 20 hours charging, no. As a rule of thumb, if you have a battery which you use to drive, you get a certain amount of kilowatts. It's power which you use this battery for. The charging is about the same as the discharging. So if you have made a battery which can be discharged, let's say in 2 hours, then it takes you 2 hours to charge it. Obviously, there are techniques to charge faster, but then you lose lots of energy. The energy you lose is the potential times the current. And the potential is the current times the resistance. So it's the resistance times current square. So if the current goes up, because you're shorter charging, you get more energy loss. These houses are in northern Friesland, and they are total energy neutral. So the heat of the summer is going to be pumped into the soil, and in the winter is recovered. These houses are 450,000 was used for making them energy neutral. You can make a very easy calculation. The next 20 years, no energy bill, instead of 75,000 euros investment. It's okay. It's economically viable. The only problem is the bank. Because if you don't have this money, you want to borrow the money from the bank. But at the moment, the banks are kind of uneasy, and they don't lend you on these long terms. But in principle, the economy, it's already economical. Recently, this building, the new building of the Dutch Institute for Organic Research, so they study how nature works. And the beauty of this building was that it is an advantage, it's positive to its environment. The building itself produces more energy than it uses. In other words, neighbors can get energy from this building. The building sucks in air for refreshment, cleans the air, and put the air back, the used air. But the used air is more clean than the air which gets in. So the building is positive to its environment. The building uses water, which it gets out of the pond. The water is cleaned by bacteria, is used, drinking water, is used for toilet flushing, etc. And then the water is cleaned again and is be brought back into the pond. But there's more clean water brought into the pond than it is sucked out. It's better to the environment. And last but not least, when the building was built, before the building was built, they studied all the plants and things which were around there. They made a map of the biodiversity. And so they put gardens on the roofs of the building and made more biodiversity than was before. You can do these things. And the beauty is, then instead of being bad for the environment, suddenly you become good. And suddenly it's not bad to have 2 buildings instead of 1. It is better to have 2 buildings instead of 1. Second about, in my view, one of the most surprising things which is going to happen, and that is solar power. Sorry. This is the price of solar power. Solar power, in fact, it didn't happen in 2006. It happened maybe last year. It went through 2.5 euros per watt peak. Watt peak is the expression. Huh? Watt peak means that is the amount of watts which you get when the sun is straight up on your solar panel. 1,000 watt per square meter. So if you have a normal solar panel which you buy, unfortunately not yet in Praxis or Gamma, but it will come. A panel like this here would be something like 150 watt peak. Which means that if you put it straight on the ground and the sun is straight above, you get 150 watts. But of course, later during the day, when the sun is tilted, it's much less, and in the dark is 0. At 2.5 euros per watt peak, and you install that without subsidy, the cost of your electricity is roughly 20 cents per kilowatt hour, which is the price which you pay yourself. If you are a private person, you pay 20 cents, 20 euro cents. So that is the parity. We are already way below. Not many people know that. In fact, if you buy today, and I can give you a website, for instance, wijwillenzon.nl. If you buy solar there, the price which you get out of your socket is roughly 15 to 17 euro cents. Already substantially cheaper than the price which you pay now. Now let's be honest. Who of you knew this? That solar is already cheaper than what you get out of your socket, without subsidy. Yeah, it goes slow. But can you imagine what will happen when it really gets cheaper, like what they call grid parity, that it is cheaper than the energy from a coal plant, like 5 euro cents? The predictions is that that's going to happen in 5 years. Now take a time and go up maybe to the 13th floor and look around and see all these enormous large roofs of all, not over this building, but all these industry roofs. And imagine how much money these roofs are worth if you have solar power, which gives you energy which is cheaper than the plants, the coal plants. So if I were you, I would just go there and make deals that you can, have a lease plan on those roofs and that you can put your own solar there in 5 years from now. Solar is growing a factor 2 a year. That's called exponential growth. Exponential growth is surprising. This was going with exponential growth. And, it didn't take even 10 years for the total distribution around the earth of mobile phones. Today, 3/1000 of the energy of the world is produced by solar. And that's nothing. But if it doubles each year, next year it will be 6,000. And the year after, it will be just over 1%. It's still nothing. But as I said, exponential growth gets you by surprise. It will go to 2.5. A year later it's 5. Suddenly it's 10, 20, 40, 80. And within 10 years, you have more electricity produced by solar than by all the power plants of the whole world. Yeah. The question is, we have a limited surface area of the Earth, that is true. But as I said before, the sun shines 8,000 times more energy on the Earth than we really need. In fact, if you take about a third, not even a third, but a little less, of the Sahara, and you put that with solar, that's the amount of energy which the whole Earth is using. So we don't have a problem with surface. It's okay. Yeah. You need to transport the energy. That's also true. In electricity transport, there are lots of new inventions. You can make what is called high voltage DC cables. China has just laid a new cable, which is 5,000 kilometers long and has an energy loss of 5%. So we get into this. But it's also smart to have, of course, the production there where you use it, which you do, in fact, with houses. The rest of the time, I like to discuss a few of the projects in which I'm involved in which you can see what you could do. I mean, it's absolutely fantastic. And of course, this is a very well-known project. It is the World Solar Challenge. We started in 2001. It's a race of solar-driven cars, all the way from the north of Australia, Darwin, to the south, 3,000 kilometers, Adelaide. The very first time we were getting champion, we had a very, very high level of solar panel quality, space solar cells, good aerodynamics, etc. 2 years later, it's each 2 years, a new team with a new car, even faster, and went 97 kilometers an hour. 2 years later, oh no, I would not show you a little movie. Yeah. With the Nuna 2, we made a tour from Greece to Porto in 14 days. So that was a tour which we did with the Nuna 2 car, 7,000 kilometers. 2 years later, 2005, the Nuna 3 drove with an average speed of 103 kilometers an hour. But you can imagine, I mean, the photographer which took this picture, how difficult it is to catch up with us, realizing that the speed limit in the south of Australia is 110. So that didn't work. So we got new regulations. It gets slower, smaller solar panels. And, but again, we were a champion with 92 kilometers an hour. That was Nuna 5, 2009. we had an accident 2 weeks before the race, and the whole vehicle was totaled. And but we fixed it, and we were heading for the number 2 position. Here you see a little movie. It's taken from what we call mission control, which is the car which is behind. That's where you just do all the decisions. Last control stop at 2,800 kilometers. Michigan is 10 seconds ahead of us.
Pas op voor het midden, er zitten hele grote hobbels in het midden van de weg.
You'll see that we'll overtake Michigan, but we were cat and mouse for the whole day. Here on the left you see Michigan. You drive on the left side in Australia. That red car on the left is also from the Australian team. He's going off the curb, which is quite dangerous because the little stones, the little rocks, if they hit your solar panel, you lose energy.
Steden van Michigan.
And the last overtake is this one.
Kom maar. Oké jongens, gaat goed. Doorgaan. Doorgaan.
Niet te lang hard blijven rijden.
We moeten hem hebben. Oké, kom maar.
And of course, celebrations. Well, this time not because we were champion, we were number 2. The Japanese, they were faster. What was funny though, that when you get into Adelaide, which is all the way in the south, the finish at this Victoria Square where you have this big fountain, and of course we are used to just celebrate. But the Japanese, they were just waiting there. They couldn't celebrate, they just were waiting till we were there, and they would just, throw in the celebration. The Nuna 6 team, and in fact, it's nice, the team is formed, the Nuna 6 team is formed because I give a class about solar racing, but the class is basically given by the previous team. So the Nuna 5 team gave a class last year on, how do you make a solar car? And from the students who follow the class, there are always a few which then say, hey, we would like to be in a team. So this is the Nuna 6 team. They are all in Australia now, in Darwin. The Nuna 6 vehicle is there too. The vehicle is again has the aerodynamics, which is even better. I mean, the aerodynamics is so good that if I take a piece of paper, I take this piece of paper. If I drag this through the air, it has more drag than the Nuna. In fact, I have to make it this small, really, that you have the same amount of drag. It's unbelievable how little drag it is. For those who want to make calculations, 100 kilometers an hour, the air drag is 40 newtons, 4 kilograms. Oh, by the way, I go there next week, and I'm the advisor, the coach, and we're going to make the last test and the optimization strategy. And I have a little secret to share with you. We're going to win. Yeah, that's okay. Since 2006, my team here on the 10th floor have been involved in designing also a race with little boats over the route in Friesland, where we used to skate 220 kilometers in 5 days. And these little boats, they're fast. This one was the winner in 2006, and the maximum speed was 13 kilometers an hour. This was already faster than you allowed. You're only allowed 12, so we had to have new regulations. But 2 years later, in 2008, this one went 20 kilometers an hour, max speed. And in 2010, 28. And then there's a new team also from the University Delft, which was visiting me last week, and they were talking about, a boat which is not a boat anymore. It's only like a hydrofoil with a very lightweight aerodynamic shape on top. They're talking about 32, 33 kilometers an hour on Dutch Sun. Isn't that amazing? I was in Dokkum, which is a little village, and a little city, and there's a small canal, and this boat passed by, and you know, it passes by, you don't hear anything, there are no waves, but it goes fast. And there was a father with his son of 8, and the son said, "Dad, if I'm old, I want to have a speedboat like this." It's new, eh? There's still people who are in the old-fashioned culture and think that, you know, lots of noise and whoa, lots of power, that is the key thing to do. But that also has grown. That was not that way 1,000 years ago. And so this will disappear. And at some point in time, we will enjoy speed, but then speed at no sound. I can tell you it's fantastic to drive in an electric car at high speed or accelerate, and you almost don't hear anything. It is something new, I know, but we will get used to it. Another thing we do is with kite energy. We're using surf kites, and we make energy out of surf kites. And this is one of our workers here. This is Rolf van der Vlucht. Rolf van der Vlucht is the Dutch champion speed kiting. He goes 90 kilometers an hour. If you look at the left, and he likes water which is very shallow, because that's where you go fast. I've asked him several times, I said, "Well, what's going to happen when you fall?" And he looks at me and says, "Well, I don't fall." The amount of power in a kite is enormous, what you can have. And what you do is, we call that the ladder mill concept. A kite, as you know, most of you have had kites in their hands. A kite goes up relatively easy. You just have to basically release the line. But when it goes up, it pulls. So you can imagine that it pulls and drives a generator to make electricity. But of course you can't go on forever. But then if you look at an airplane, then you may be realizing that an airplane just is the reverse of a kite. A kite goes up easy and goes down difficult. An airplane goes up difficult because you have to have an engine, a propeller, and fuel. But it goes down easy. You just switch off the engine and the airplane goes down. It's just a glider. So if you go up like a kite and you pull, and you go down like an airplane and you don't pull, you can transfer energy. A little bit in the way this was foreseen. So you have many kites going up, they're all pulling very strong, they fly down as an airplane, and on the ground you have a ground station with a big wheel and you generate energy. And the nice thing, of course, is that above there's much more wind energy than below. I show you a little movie of where we are basically today. We have developed what we call a steering pod, is going to control the kite, but then not by hand, but by computer, such that we can have an autopilot. And this is the kite which we fly. In fact, we flew yesterday also in Valkenburg, is the old airfield close to Katwijk. And with a kite like this, we can go up to 20 kilowatts of power. And the nice thing is that what we do is we fly the kite in figures of 8 to pull very strong while it goes up. And then it flies down as an airplane. And on the ground we have the generator. And the cost of the energy is extremely cheap. It's also mobile. You can move these things to developing countries. The ground station is just on a truck. It's not like a wind turbine where you have to make a tower. Here you see a little camera which is in fact on the line, and on the left, on the right you see the power. In fact, what we did in Groningen once is producing the power for a rock band, and that was really fun. That was Jan Akkerman.
Oké, Groningen. Het wordt weer het principaal is begonnen.
you can imagine that these things are lots of fun to do. In fact, the innovation which is the result of becoming sustainable is so much more fun than what we had before. This is the ship which I could build because I sold that very big house which you saw earlier. But this is not a normal sailing ship. It is a ship which generates its own energy, which is autonomous, and its own water. While sailing, the propellers underneath are rotating as windmills, and they store the energy in batteries. Everything under the floor is batteries. It's almost like a submarine. So many batteries do we have, 12,000 kilograms. We could live 3 weeks on board with all the luxury, normal luxury, even with dishwasher and a washing machine and a dryer and showers and heating and everything and cooking. And then we have to sail. And while sailing, of a typical speed of 10 knots, one of those propellers produces the amount of power equivalent to 20 households. Because I would like to make a point that sustainability does not mean less, it means different. It's fun. You can have pleasure with it rather than having to reduce the things which you do. Here you see the baptizing, and it sails to Scheveningen, which is now the home base of the ship. The last project I want to address to you is a Superbus. Superbus is a new type of public transport. With the logo which you see here is the S and the B, but the B is a heart, and in fact the slogan of Superbus is service to your heart. It's a public transport which wants to beat all the other public transport. It wants to change the paradigm of public transport. Public transport now is most of the time considered as a little bit lower lifestyle than what you have when you have a private car. It has changed somewhat when you look at the high-speed train, the Thalys or the TGV. But what we want to do with the bus is that Superbus is also making this change because it's a high-speed bus. Superbus drives 250 kilometers on electricity. The team which leads Superbus are these three people. Of course, you know me. In the middle, Antonia Terzi. Antonia Terzi she's Italian. She did her PhD with Ferrari, and she worked later on as a chief aerodynamicist for BMW Williams Formula One. And so she made the vehicle. And on the right, you have, on the left here, you have Joris Melkert, and he is an aerospace engineer. Superbus is a vehicle which has seats for about 25 people, luxury seats, and has a style of a very luxury car, like a limo. Superbus is as long as a normal car, it's as a bus, it's as wide, and it can drive everywhere where a normal bus can drive. And so Superbus is in that respect new, that it combines the services of a high-speed train with the flexibility of a road vehicle. And that gives you a big advantage because, you know, a high-speed train, if you would have a high-speed train from Schiphol to Groningen, it would pass through Flevoland, but then Flevoland would not have an advantage. It only has a disadvantage of something passing by at very high speed with lots of noise. But Superbus drives on a special track in the middle of the highway very fast, but then each 20 kilometers can change to the normal highway and to the normal roads and can service also the cities in between. Superbus is really high-tech. It is all carbon structure. It has 750 sensors for doors and all kinds of things. It has very strong electric motors, each being 120 kilowatt, four of those motors at the rear wheels. It has a big battery pack in the rear. This is the carbon structure, which is extremely stiff, with 8 doors on both sides, such that you can get in and out without disturbing other people. Here you see some of the production molds. As I said, the steering on the rear wheel. We have radar for anti-collision. It's much more easy with a Superbus to have safety than with a train. A train needs about 5 to 10 kilometers to stop at high speed. Superbus 200 meters. So with Superbus, we just think that a distance of 400 meters is safe. You can even see the vehicle, and if something goes wrong, you just go down on your brakes. Superbus was compared with other systems like the high-speed train, like the magnetic levitation train, the MZB. And the amount of passengers which Superbus will attract is much higher because of its flexibility. The infrastructure costs are much lower. I mean, a train system is expensive compared to a road. And the business case of Superbus with train ticket price, which is for many people unbelievable, but Superbus can have business with normal train ticket price, second class. Superbus is not only for passengers, but we want to combine Superbus with parcel services. And in fact, this was the boss of TNT, Peter Bakker. Superbus got money from the government to make and produce a experimental prototype. And so that's what we did, and we launched it last year in Hanover. So this was the very first time that Superbus saw the daylight. Here you see the wing doors. Wing doors because they're nice. Superbus is really becoming a showpiece. And in fact, we were in Dubai with Superbus to promote, to have Superbus driving from Dubai to Abu Dhabi. And there was a little bench here. And I invited the ruler of Dubai, is Sultan Mohammed. He is the real boss. And I said, okay, now sit down and look at the rear of this vehicle. And imagine that you bought yourself a new Audi 8. Beautiful, you drive 200 kilometers on the highway. You enjoy all the luxury which you have. And then suddenly you're overtaken by something which looks from the rear like this and is called public transport. Here you see some more pictures. And in fact, here you see a picture of the rear steering. So you see, Superbus can really make sharp turns. And this was the very first trip. And listen to the text. Yeah, Superbus. Here you see some more pictures. We are testing regularly at Valkenburg Airport. So if you want to see Superbus, if you want to see Superbus, you can just basically go there and look. We are promoting now Superbus on the first pilot track, which we hope will be approved, and that will be Heerenveen, Groningen. And we will have a special road there, which is using the heat of the summer to make it ice-free in the winter. And 7th of August, Superbus was in Assen at the TT. 60,000 people stood up and applauded when they saw Superbus. Superbus is an emotion. Superbus is like a car. It's like what we said before. You do not choose for the cheapest. You choose for what is touching your heart. That is the way Superbus acts. Well, I have many lessons learned, and what I want to do is, basically I want to conclude with, not so much with lots of text, because I have text and it's not so important. But I want to conclude with something which is really where it's really about, which is sustainability. These, by the way, are the people at Lowlands. We're going to make Lowlands sustainable next year. But the real key issue is that if you really believe that we will make the right choices, that we go to a sustainable culture very quickly in a very elegant way, if you really work on it, then you feel that you do something good. And that feeling of doing something good, in my view, gives you extra energy. Extra energy of, yes, I have the right direction. And this extra needs to be there. You know, if you want to survive, let's face it, there must be a reason why people go in the right direction. It's called Darwinism. You need to multiply yourself. That's why sex is pleasant. That's why. We have to go into a, yes, we have to go to a sustainable direction, and that's why sustainability should be pleasant. Don't think it is worse, it is better. I call this happy energy. Happy energy is a logo which you see here on the right. You can go to thehappyenergy.com and look at it. Happy energy is the same way. Are you all looking at peace? Happy energy is something which is pleasant. And I want to finish because I don't have more time to explain sustainability with you. But I hope one thing is clear to you. Going towards a sustainable society is challenging, but is also extremely rewarding. You can invent new types of airplanes. You can invent everything new which has still to do with fossil fuel because we can't afford doing that in the future. And if you do that, then if you look into the mirror in the morning, you don't have a question, why do I live? Because it's clear. You feel more energetic, you have better stories to your friends, and you just have more joy in your life. I wish you all the happy energy you can get. And if you're really serious about happy energy, if you really believe in it, then maybe you can go to Henk Schiefmacher and have a tattoo. It was a pleasure talking to you. See you.
Please visit our OpenCourseware website for more information. See you at our next